So here's a question that looks at the inverse trig functions, and there's a little bit added on to the end for fun. Okay, so the first thing I'm going to do is to look at arc cos x. When you use the arc cos or the cos to the -1 function on your calculator, you're trying to find an angle, and you do cos to the -1 of 0.2 and it will give you an angle. So arc cos x is an angle. I'll call the angle A. So if arc cos x is A, then x must be cos A. And I can write that in a slightly different way. Cos A equals x divided by 1. And the reason I've done that is I want to show this on a diagram. I'm going to use the diagram of a little right-angled triangle. So there's my right-angled triangle with the angle A shown, and if cos of that angle is x over 1, that's adjacent over hypotenuse. So those sides must be x and 1. Okay, so then what is this angle here? If this is A down here, then this is pi over 2 minus A. So that angle there is pi over 2 minus A. So what is the sine of that angle? Sine of pi over 2 minus A is opposite over hypotenuse, which is also x. So that means that when I do the arc sine of this, I can get pi over 2 minus A equals arc sine x. So now I'm in a position to prove my result up here. Arc cos x plus arc sine x that's what arc cos x is, that's what arc sine x is. So those two added together is A plus pi over 2 minus A, and that's pi over 2. So there we are, that's the proof. When you take that approach, it looks relatively straightforward, I hope. There are other approaches that can be taken, but that I think is by far the simplest approach as far as I can see. Let's just pause for a moment and see what else we can do while we're here. For example, we can use Pythagoras on this triangle to find the length of the third side of the triangle. And then what we can start doing is looking at for example, the tan of A. And the tan of A is the opposite over the adjacent. So that means that when we take the arctan of that, A is arctan of that expression, the opposite over adjacent. And so A is arctan of this, but A is also arc cos of x. So therefore, arctan of this is equal to arc cos of x. So that's another result that we can derive from this approach, one of a number. Okay, interesting stuff.